This video is the second part of section 1.3 for college algebra. I'm sorry I didn't label the slide very well, but again, this is part 2 of section 1.3. We're going to start talking about adding and subtracting of complex numbers. Complex numbers, because they're in the form of a plus bi, we have a real number part, the 3. We have the complex number part, or the imaginary part, of -4. And when we add and subtract, it's kind of like adding and subtracting like terms. The 3 goes with the -2, so 3 minus 2 is 1. The -4 goes with the 6, so -4 plus 6 is 2i, and we're done. So relatively easy. It's kind of like combining like terms. So if we do -4 plus 3i minus 6 minus 7i, the biggest thing to remember is it's kind of like we take the minus sign in the middle and we distribute it. So you still get -4 plus 3i, and then minus 6 plus 7i. The reason why it's plus is because a negative times a negative is a positive. And again, now we're combining like terms. So -4, -6 is -10. +3, +7 is +10i. So we get -10 plus 10i. Multiplication is not much different. Multiplication of complex numbers, you just have to remember to do FOIL. Okay, if you remember, FOIL is first times first, outside times outside, inside times inside, last times last. So the 2 times the 3, first times first, is 6. Outside times outside, 2 times the +4i is +8i. Inside times inside, -3i times +3 is -9i. And last times last, -3i times +4i is -12i squared. Now we're going to look at the -12i squared first. We remember back from part 1 of the video that I squared is -1. So -12 times -1, and a negative times a negative is a positive, so we get +12. And now all we have to do is combine like terms. So 6 and +12 is +18. +8i, -9i is -i. So we get 18 minus i. Another example here. We got 6 plus 5i, 6 minus 5i. Some might recognize these from Algebra 2. 6 plus 5i and 6 minus 5i are conjugates. The reason why they are conjugates is because the first number and last number are the same, and the only difference is the sign in the middle. What happens when we multiply conjugates? The outside, outside, inside, inside terms end up canceling each other out. So we start with 6 times 6 is 36. Minus 6 times 5 is -30i, plus 30i squared, 30i, and then minus 25i squared. So the minus 25i squared, we're going to take care of that first, and becomes plus 25. The minus 30i plus 30i cancel each other out, and 36 plus 25 is 61. If we needed to, we could write it in a complex form of 61 plus 0i, but that would not necessarily be practical. Dividing complex numbers, okay? If we remember, I'm putting a little note up here, we cannot leave I in the denominator. It's not standard form. It's not simplified, okay? So another reminder here, we need to multiply by the conjugate, okay? So the conjugate of 5 minus I would then be 5 plus I. So we have 3 plus 2i over 5 minus I, that's our problem. We're going to multiply top and bottom by the conjugate of the base, so 5 plus I on top and on bottom. When we multiply the bottom, okay, we notice that plus 5i minus 5i is going to cancel out. Negative I squared, that means -1, which is a +1. So we get 26 in the denominator. In the numerator, we're going to FOIL. 3 times 5 is 15. 3 times I is 3i. 2i times 5 is 10i. And 2i times I is 2i squared. Again, the 2i squared is going to become a -2. So we get 13 plus 13i. Now, we're not done because we need to make sure that we simplify. Notice that everything is divisible by 13. So 13 divisible by 13, 13i divisible by 13, 26 divisible by 13. So we get 1 plus I all over 2. Another example, if we have 3 divided by I, we multiply top and bottom by I. In the denominator, we now have I squared, which is negative 1, and that simplifies to negative 3I. Again, remember, if you need to pause the video to catch up on your notes, just pause the video. And the last part of complex numbers, part 2. Okay, so we're going to start with square root of negative 1 is I. And if square root of negative 1 is I, and we square that, let me get my video right, and we square that, then I squared equals negative 1. We know that part, okay? Now if we have I cubed can be the product of I squared times I, or I times I squared, okay? I does not simplify. I squared is negative 1. So if we have I times I squared, it's negative 1 times I, which is negative I. I to the fourth, we can rewrite it as the product of I squared times I squared. Well, that's negative 1 times negative 1, which is just 1. Okay, so if I rewrite this, negative 1 is, the square root of negative 1 is I squared is negative 1, I cubed is negative I, and I to the fourth is 1. That develops a pattern that repeats itself. If we come down here to the bottom left, we see that I to the fifth is I times I to the fourth. Okay, so I times I to the fourth. We remember I to the fourth is 1. So 1 times I is just I. I to the sixth, we can kind of repeat the pattern. I'll let you watch this and take notes here. Okay, so notice in purple we have I, negative 1, negative I, positive 1. And that's a repeat of the pattern that we have up in the box in the top right. So it repeats every fourth. So if we now have a problem, I to the 24th. Well, if it repeats every 4, how many times does 4 go into 26? Well, we kind of know that. 4 goes into 26 6 times. So that's I to the fourth 6 times. Well, what's I to the fourth? Positive 1. Positive 1 to the 6th power means 1 times 1 times 1 times 1 times 1 times 1. I think that's enough. And all that equals 1. I to the 30th. How many times does 4 go into 30? Well, it doesn't go in there evenly. Okay, we take 30 divided by 4, we get 7.5. Well, 0.5, right? So 7 times, 4 goes in there 7 times. 0.5 is half. Half of 4 is 2. Okay, so we can rewrite that as I to the fourth happens 7 times, I squared. Well, I to the fourth is 1. 1 to the 7th power is still just 1. I squared we know is negative 1. So I to the 30th finally simplifies to negative 1. Okay? When we use our calculator, so in the line in blue where I took 30 divided by 4, I just use a calculator. We get 7.5. The 0.5 tells me that there's a remainder of 2. Okay, look on the top right. In purple, I put down what our remainders are. So if our remainder is 0.25, it's going to be I to the first. If our remainder is 0.5, it's I to the second. If our remainder is 0.75, it's I to the third. If there are no remainders, then it goes in there evenly, and it's just 1. Okay, so hopefully that makes sense. So I to the 81st, 81 divided by 4 is 20.25. Because the remainder is 0.25, I know that it's just I. Hopefully that makes sense, and good luck.